is actually circle theorem. And the circle theorem we are talking about, there are very many circle theorem we talk about. The one we are dealing with in this case is actually the circle theorem as stated on the board there. The angle which an arc, if you check what we have done before on circle, we said an arc, as you can see, this is the arc. The angle which an arc subtends at the center. The angle in a literal term, now speak in English. What we are saying, what we talk, we say, the angle when this arc carry, that is what it means by the word subtend, what it actually carries. If you check the angle that is carrying, don't forget the way we normally write angle in our current mathematics. We don't write it like a caret like we normally write it before. This is how we write it. So this angle, the angle that we are talking about should be at the middle. So it's angle BOC, so which are talking about angle O, right? Now it's angle BOC. What that law is telling us is that the angle which this arc, can you see it? Arc, that curve a small portion of the circumference. The angle which is carrying, which is that was what the word subtend. That's what it means. The angle which it carries, this is the angle which it carries, is equal to times 2. That's why I say twice. The angle which it carries at any other part of the word circumference. That is, it's resting on that angle that is carrying. Do you understand? It's resting on that angle that is carrying. This is not the only form we have it. We have about 3 forms of it. This one is just the first one. I'm going to bring it. Do you understand? So what this one is simply telling us is that this angle which the arc, that is the word subtend, the angle which the arc subtend is equal to times 2, that is twice the angle that is subtend at, that is the angle which it carries at other part of the word circumference. Don't forget, it's carrying it at the center. That's why we say the angle which an arc subtend at the center is equal to twice the angle which is subtend at what? Any part of what? The circumference. You see that this one now is not resting on the circumference, still resting on this angle which the angle the arc carries at the what? Center. Do you understand? So now it's twice. Please take note of that. Whenever you are calculating, you should know that this angle at the center is equal to twice the one that is subtend at the what? Circumference. And whenever you are doing calculation, you must give your reasons if you are solving. That is what we have here. I'm going to give you another form of this again. Before maybe subsequently we'll talk about calculations that involve them. Now I want to clean the board. I'm still going to give you another form in which this law, this theorem exists. I'm going to give you another form. It can also occur in this form. I will try to use the same alphabet. Now you can see what we are having on the board. This is this. This angle is also subtending at, this is angle O. So this angle, it will not be like this. Can you see it? So you will see that this angle, this arc is subtending this angle at the center. Don't forget, the mistake that we normally make sometimes is we always forget that we are dealing with this angle, not the one inside. Do you understand? The angle, sorry, we are dealing with this angle, not the one outside. This is the angle we are dealing with. So this angle which is subtend at the center of the circle is the angle here. This is the angle. The angle which is subtend at the center of the circle is twice this one here. So I can label it here as A, here as B, and here as C as usual we did it before. Now you now see that we're now having angle BOC like we did earlier is equal to 2 times angle BAC. Angle BA. Let me use this angle BAC. Angle BAC. Can we see that? So what we are